All right, coming up next, we have Kevin Thayer with eBay and Ron Lewkiewicz with Juniper. Hope I didn't butcher that, Ron, sorry. They'll be talking about how to replace this all with a very small shell script.
All right. Hey, everyone. I'm Kevin. This is Ron. Funny thing, we actually talked about replacing our previous sales guy with a Slack script as he exited. Anyways, I'm Kevin. This is Ron. I'm from eBay, and I'll be talking about sort of the progression that we made going from a standard or legacy VLAN non-routed network to a routed network. Some of the technologies we had to develop along the way, and some of the new stuff we're working on. So let's get started here. They told me that, ooh, no? Hey, I'm pushing all the buttons.
Expert is running back there to resolve.
All right, great. All right, how do I go backwards? All right, there we go. Hello. There we go. All right, so we've operated a multi-vendor routed network since around 2009. That's when we made the switch. And we'll talk about some ways we solve the problems. And we've chosen the approach of working with our partner vendors to help us develop technologies that we needed that were not yet available to help us automate our infrastructure. So today we'll be talking about switch build automation, which is ZTP, which has been around for a while, but I'm proud of it, so I want to talk about it. Simplifying administrative cost out of links in a BGP as IGP network, along with a lot of you guys. We're moving to a BGP as IGP network, and we're going to talk about some of the challenges we face operationally. And lastly, we have a lot of Tor switches, top rack switches. We're talking about hitless code upgrade on those, and some future stuff. All right, so I had a bunch of slides here about how we beat up our vendors to make them do things, but I'm going to skip all that. The CliffsNotes version is basically operate a multi-vendor network, and you get a lot of benefits from it. All right, so going back to 2009, we were in a 6500 end-of-row design and starting to think about moving to top-of-rack switches. And when we looked at this, we said, hey, we're going to have 10 times the number of switches that we had before. And within the team, there's a lot of animosity towards, hey, I have to build 10 times as many switches. That's more devices to manage. It's more work. We don't have the people to do that. So we had to find ways to operate in that mode. So we also, whenever you have people doing, if you have 10 different people building 10 different switches, they're going to do things slightly differently. So we got inconsistent implementations. We got to get out of that. And also, side effect, if you have humans doing repetitive tasks, they're going to screw stuff up. So our concept was 100% automation. The only human involved is the one that racks the switch. The guy in the data center puts the switch in the rack, screws it in, plugs it in, connects a fiber, done. We wanted to use industry standard tools. We didn't want to reinvent anything. This is stuff that the server administrators have been doing for a long time. If you have a lot of systems, you find easy ways to build it. And configuration and code image. At the time, there were quite a number of solutions that would allow you to use DHCP to pass a configuration file, but none of them which would do the actual code. And the way we looked at it, we said, hey, the best way to do this is have the switch configure itself using some sort of script running on the switch. All right, so there's two ways to do it, actually. There is a way that you can do the sort of the classic DHCP model, where you pass a configuration file in one DHCP option and a code file in another DHCP option. Those can be URL encoded, so http://file, and you can configure a whole switch that way. That works. We've done it. The problem is that it requires a lot of tie-in between your DHCP infrastructure and your provisioning. At eBay, we, the network engineering team, do not manage the DHCP server, so we needed another solution. So that brings us to orchestrated ZTP. So you require the minimum amount of information about a switch in advance. You don't have to have a specific serial number of switch, go into a specific rack, none of that. Where you plug it in determines where it's built. Configuration can be automated, and you don't have to personalize anything until the very last moment. Also, we use ZTP for RMAs, so we back up all of the configs of our switches, and when one fails, we have the site services guy replace it, comes up, gets its previous configuration, boots up, and it's happy. All right, so I'm going to walk you through what our provisioning flow looks like. We're going to be provisioning a new switch, the one with the glowy blue bubble around it. So the first thing we do, switch plugged in, powered on, and starts to send out DHCP requests. The DHCP server will receive that, and based on the vendor string or whatever else, will say, hey, this is a Cisco switch, this is a Juniper switch. We'll use Juniper for this example, because Ron's up here with me. And it'll give it a script, the Juniper auto build script. The switch will execute that script after it downloads it, and the first thing it'll do is hit a CGI on a separate server, which is maintained by our team. What it does is basically asks for its configuration file. And the web script, step 3, will take that request, look at where it came from, so the source IP address of that, that build request, and say, oh, I can see that you're on this subnet, that's on this switch, based on our database. If it's a layer 2 port, it will actually crawl the network to find out exactly where it's plugged in. And based on the name of that port, it will determine the identity of that switch. So we, as long as there's a port name, that's where it'll be built. And we have had some problems with this, that if someone plugged the switch in the wrong port, it gets built with the wrong image, but that happens. All right, so then finally the script will, on the switch, will receive the configuration file, look in that configuration file to see what code version it's supposed to run, see if it has that. If it doesn't, it will download it, and then apply all those things, reboot, and you're good. All right, so this is one of the first sort of industry influencing projects we had. We had to go to all of our vendors and say, hey, we need this feature. And it's kind of an uphill battle. Vendors didn't want to change the default boot mode. We still hit that in some cases. As we moved into 10 gig and 40 gig uplinks, we have both types in our network today, and we have switches that one day may be a 10 gig, and if you plug it somewhere else, it may use 40 gig uplinks. And there wasn't a 10 gig, 40 gig autosense for fiber at the time, and so we had to figure out a way to do that. Down the road, we're looking at using LLDP as identity discovery. Another thing we're sort of pushing our vendors for that hasn't happened yet is ZTP in a box. So have like a VM image that you can get that'll have everything sort of preset up for you so you can play around with it. I'm a big believer in if you can get something working in about 10 minutes, you're much more likely to use it and find benefit from it than if you have to sort of build it all from scratch. So along the way, we learned a number of lessons. One of the first ones is that booting in layer 2 mode may be easy and is the path of least resistance for vendor implementations. And what this means is if you take a switch, it boots up as a switch, all the ports are in VLAN 1, make yourself a VLAN interface for VLAN 1 and send a DHCP request from that VLAN interface. Sounds simple, works. Unfortunately, we buy pre-integrated racks, so we have all of our servers already connected, and we do 48 servers per switch, so we have one VLAN interface and 48 servers, and all of them are sending out DHCP requests, and so you have a 1 in 10 or 1 in 40 chance of actually getting an IP address and building. Another thing we found out that if you're plugging this into a layer 2 environment, there's a lot of protection mechanisms that exist to prevent rogue switches from being connected to your network. BPU guard, native VLAN mismatch, spanning tree protocol, all kinds of things will prevent you from actually connecting to the network because the upstream switch will disable your port. And also, assuming that none of that does happen, the distribution switches that you're connecting to may form adjacencies with one another because you have a layer 2 semantic. So we've spent a lot of time with our vendors to sort of convince them that these are all bad things. The second big lesson learned is that don't try to be too clever in, if you encounter some sort of problem while you're building, just restart the process. This is an automated thing. It'll go around a few more times. And if you need to fix it, you can just fix it on the server in the back end. All right. All right, transitioning to the next topic, BGP cost out simplification. So we are transitioning from OSPF as our IGP to using BGP. There's a lot of scalability benefits. And we thought about, well, what is this going to look to our operations team, like our NOC guys, and what they have to do? So today, if you want to take a link out, drain traffic from it, it's a fairly straightforward operation. You go to the router, you go to the interface, you change the metric. You have to do that on both sides. It's easy. Okay, well, now we throw in IPv6 because we run IPv6 too. So you have to do an OSPF v2 and v3. Just one more step. And you can use max metric and the associated commands for draining the whole box of traffic. All this stuff works. It's pretty straightforward. Okay, so when you go to BGP, costing out a neighbor, you don't actually cost it out. You apply a route map. And you don't actually do it to an interface, you do it to a neighbor. So now if you want to make this change to remove an interface from traffic, you have to know the neighbors on the interface, and you have to know the route map that you want to apply. This is a lot more thinking than just going to a device and going to an interface and applying a metric. All right, so how can we simplify this? It would be nice to handle everything at once, however many address families we have. And what about draining traffic in both directions from one side? So you go on the distribution switch, apply your configuration, and the traffic goes away. Sounds awesome. And do we really have to do neighbor lookups? I just want to cost a link out. I don't want to cost a neighbor out. I realize that that's what's actually happening in the back end, but I want that all to be hidden. So as we thought about this, we said, hey, if we're going to ask vendors to work on this for us, this can't be an eBay-only solution. We use eBGP, we use prepends, but other colleagues may choose different ways of doing it. So we said, hey, if we're going to do this, a user-defined route map is probably the best way of doing it. So we went to our vendors and said, hey, can you guys build this for us? And we got a number of different responses, and I think Ron is going to talk about the Juniper one.
Sure, thank you. Yeah, so eBay came to Juniper with this problem, and we wanted to come up with a flexible solution that worked for eBay as well as any other customer. So although eBay might choose to use ASPath prepend to take an interface out of production, and we again wanted to make sure it's going to work with any sort of user-generated policy, whether it be MEDS or some other method. So what we did in the short term is we created and gave eBay a Slack script that runs on box. It looks for a predetermined policy to be already configured on that box, but that policy can be, again, whatever the user deems it to be. And all you give the script is an interface name. In this case, it's Ethernet 11.1.0. You tell it to disable. In this context, it means to take it out of production. And then you could see it takes both the v4 and v6 neighbor out of production. And then similarly, you enable it, bring it back in production. In the longer term, we're looking to implement this as an OS feature, but just to get this out the door, we went with the script method first.
All right. Cisco has also implemented a very similar solution. It's essentially identical. There's a script, it runs, it does a thing. We don't have to talk about that too much. Also relevant in this space is GSHET, and I'm not going to go into full description of exactly what GSHET is, but it's a new standard. Hopefully a lot of you are familiar with it. If not, there's some information here included in the slide for reference. All right, lastly, this is something that I'm very excited about is ISSU. So ISSU is the ability to upgrade a switch to a new software revision without losing packets, continuously in service. It's been around for a long time, so why are we talking about it? What is new or special about ISSU? So as we looked at ISSU and the capabilities at eBay, I said, look, ISSU is currently a chassis type feature. But a chassis is really the worst place for ISSU because, I don't know, in our experience, anybody who's running a data center, and I'm a very data center guy, all their chassis, it's easy to take them out of production. You run an OSPF or a BGP route map, and the traffic magically goes away. You can unrack the switch, you can replace it, you can hit it with a hammer, you can do whatever you want, and when you're done and you decide it's working again properly, you put it back in production. So it's easy to do. There's no need to run ISSU there. However, on the TORs, we have over 2,500 TOR switches in our network today. We do not have this magical software in all cases that can handle switch failures. We have to coordinate outages. Coordinate upgrades is a very painful process. And with thousands of switches, if we wanted to upgrade them all, it would take us years, really, to do. And it's sort of like painting the Golden Gate Bridge. Once you finish, you have to start over again. You're never going to get there. Also, we can't consume new features. We really aspire to be on the bleeding edge of some new technologies, and we just can't get there if we can't upgrade our code. And despite all this, it is actually not that big of a deal if we lose any given switch. So if the ISSU doesn't work perfectly, we're happy to provide feedback to our partner vendors and say, hey, this didn't work, attack case, figured out. And we're not going to be too mad about it. All right, this is a long-term project. We started about 2 years ago saying, hey, we think this is something we're going to need. And we think it's going to take you about 2 years to get there. So we went to all of the vendors that we buy from and said, hey, this is something we're interested in. All the vendors took a slightly different approach to solving the problem, but we did actually get some solutions, at least on the roadmap for this. So I'll let Ron, again, talk about Juniper's solution.
Sure. So as Kevin mentioned, the concept of ISSU, there's really nothing new about it, right? It's been around forever on chassis-based systems. What's interesting from a top-of-rack switch point of view of how it's implemented. So in traditional chassis, you have you have two routing engines or supervisors or brains, what have you. In a top of rack, you usually just have one. So there's multiple ways of accomplishing this, and no way is necessarily the right way. The way Juniper approached it was to take advantage of multi-core CPUs and virtualization. So when you're not running ISSU, there's just one brain on the system. There's no backup routing engine, so to speak. When it comes time to issue an ISSU, we spin up a new VM, which is going to be the new master. We synchronize the control states. We synchronize the PFE or ASIC states over. Once that has all been synchronized, we do a hot handoff of the ASIC from the old master VM to the new master VM. We then kind of destroy the previous backup or previous primary routing engine, and you're done. So when we were designing this, our goal from onset has always been 0 packet loss. That's not necessarily something that's easy to achieve. So in the code that's actually shipping today, in a BGP clause design, meaning there's obviously BGP, both v4 and v6 running, we've demonstrated 40 to 60 milliseconds of packet loss, which I think is a pretty good start, but again, our goal is 0. Our other design goal is anytime a new feature is released, it's going to be ISSU capable from day 1. This is software, so that doesn't always happen. There's always caveats to read in the release notes. One, for instance, VRP isn't supported yet. But again, that's the design we're looking to achieve. I think that's it.
Great, thanks, Ron. I just want to reiterate that this is a shipping thing, and it has 40 to 60 milliseconds of impact for a code upgrade, which is pretty awesome in my book. All right, we were going to have a slide about Arista, but they have recently filed S1 and gone into their quiet period, so I can't make any forward-looking statements on their behalf, other than to say that they have committed to releasing a feature that will meet our requirements. Cisco is also working on ISSU for their Nexus 9K series switches. And it's a very similar approach to the Juniper one. They'll spin up a new hypervisor, handoff to it. Not a lot more to say about that. All right, so there's been a bit of debate that I've had with some other prominent members of the community about whether ISSU on tours is the right thing. Going back to the very beginning of, I think it was the first or second day, the don't ask for things that you don't necessarily need, and make sure you're asking for things that you do need. So there are other ways to solve this problem. You could do multi-NIC. You can have your servers connect redundantly to the network. The reason eBay needs this is we're single NIC. If you do multi-NIC, it doubles the number of tours, reduces the available bandwidth in a redundant fashion, and you still really do have the same failure domain given that you're sharing a VLAN typically. The next objection I sometimes get is, isn't it just masking application design deficiencies? If your application was really good, it should be able to detect that the switch is no longer working, and any systems that were attached to that switch should just be gracefully removed from production, and everything should carry on. And I absolutely agree with that objection. I wish I lived in an environment where applications were that smart. And in fact, some of our applications are that smart. Our search, the eBay search engine, is very, very good at this. We don't have to worry about it. But we are starting to run an internal cloud, and we don't have any control about what applications are deployed, so we can't really do it. The last one here is the code development complexity question. It's going to slow down the feature release if you have to make everything ISSU capable. There's going to be more bugs. Features are going to take longer to develop. And so I agree with that. That's true. However, it does me no good to have all these great features if I can never use them on my network. So I'd rather have slower feature development and be able to use the features than have a million great features and never be able to put them on my network. All right, so I want to talk about a few things in the remaining time that we have about features that are on the roadmap. One thing is, one of the trends I've seen in networking is that scripts and modules and extensions to, we've talked about a few things the Comcast guy shared earlier about ways to augment switches. And as it comes out, if these are not operating system features, it is very difficult to back up and restore switch personalities if they aren't in the configuration proper. If you have a switch that has a hard drive essentially attached to it and there's a bunch of scripts in there that define how that switch works, if you're going to restore that switch from an RMA or from whatever else, it's very difficult to know what's there if it's not in the configuration file. There just isn't a mechanism to do that. So we've asked our partner vendors to say, hey, give us a device personality blob. Here's everything that makes this switch what it is as an atomic backup and restore. So instead of, copy startup config to TFTP, copy device personality, TFTP, or what have you. Another one is high-resolution metrics and compute clusters made of switch CPUs. So as part of the upshot of this ISSU thing, vendors are starting to put more powerful virtualization-capable CPUs in their switches. So as we've looked at sort of collecting NetFlow stats from all of our switches, it comes out that you almost need a whole server to capture and process NetFlow statistics from a single switch at high speeds. And so I have to have a Hadoop cluster or some other cluster of compute to sit there and process all this data. Every time I add a switch, I have to add a server. Every time I add a switch, I have to add a server. And we sat down and looked at it and said, hey, every time I add a switch, I add this huge CPU now that's sitting there doing nothing. Can I run a VM on that and have my switch cluster also be my compute cluster? So that's something we're looking at, doing a multi-vendor pass at to see if we can get a system to do it. If it turns out that storage is the big problem, it's not going to help, but that's something that we're looking at. I'm going to skip over the overlay SDN controller one. There's a diagram there. It's going to take a long time to explain. And the last one I want to talk about, something that I'm kind of excited about, is what I call virtual MLAG. And I have a slide for that here. All right, so MLAG is a technology that allows two switches to act as one switch from the case of anything downstream from it, and running Ether channel to that pair of switches. And one of the things that MLAG has is a link that connects the two switches directly to each other. So when you do that, say you have a switch that has 4 uplinks. So you have to take 2 uplinks that connect to each other for redundancy, and any layer 2 shortcut traffic goes through there. So that reduces your uplink bandwidth. Instead of having 40 gigs, you have 20 gigs, and a few other undesirable things. So as we're looking into the SDN, VXLAN type thing, where you have all these layer 2 tunnels flying around everywhere, why not make that tunnel between the two switches a virtual tunnel, instead of an actual physical layer? So you connect them with a virtual tunnel, you use your standard clause to carry that tunnel, make sure that tunnel ECMPs the traffic well so it load shares across all of your uplinks. And now you have both of those switches can have the full amount of bandwidth, less whatever sideways traffic there is. And I don't know, to me it seems like a great thing. So this is something we've been asking our vendors for and just sort of exploring. So that's pretty much it for me. I'd like to open it up for questions. And thanks for sticking around to the last day and the last talk to hear me talk. Thanks.
You've already replaced them with a script, sorry.
All right. Thanks, everybody.